Hello 8th graders, in this IXL video we're taking a look at assignment G5, which is about dividing numbers that are written in scientific notation. And multiplication and division are very related. They're inverse or reciprocal operations. They work together, they usually follow the same rule. And when we multiply or divide with scientific notation numbers, we can follow a very similar approach for both strategies. We tackle the coefficients separately from the powers of 10. Quite simply, when we're multiplying or dividing, we handle the coefficients by doing their multiplication, or in this case, their division. And then we do the division for the powers of 10 separately, then put things back together. So here for our first example, they tell us 8 times 10 to the 4th is going to be divided by 8 times 10 to the 3rd. I'm going to put that onto my whiteboard. And one thing my brain starts thinking about when I have two scientific notation numbers that divide by each other, and that's all a fraction means is division, I'm going to handle them separately. I'm going to put a red box around these coefficients right now. And I'm going to think, what does 8 divided by 8 give me? 8 divided by 8 gives me 1. And then similarly, I'm going to look at 10 to the 4th power divided by 10 to the 3rd power. And I know when I divide the same base, each copy on the bottom cancels out one on the top, so all I really do is I keep the base the same. In this case, the base of 10 is not going to change. And I'm just going to do 4 minus 3. Each 10 on the bottom cancels out a 10 on the top, so 4 minus 3 tells me if I cancel 3 of them out, there's only going to be 1 power of 10 left over. So scientific notation can be complicated, division can be annoying sometimes, but I think you'll find division and multiplication are almost easier than adding and subtracting. Just handle the coefficients separately from the powers of 10. So based on all of that, we're going to have to settle with 1 times 10 to the 1st. It lines up with what we see there. It's the only one that's even close on these. Alright, and here's our next problem. We're given division again, scientific notation again, and for each one of these, I'm going to write them on my whiteboard to show it, but you might be able to start handling these with some mental math. It's 8 times 10 to the 5th divided by 2 times 10 cubed. I'm going to just do the 8 divided by 2 first. And 8 divided by 2, quite simply, 8 divided by 2 is going to give us 4. When we do the 8 divided by 2, we get 4. And then I'm also going to do 10 to the 5th divided by 10 to the 3rd. But all that requires is keeping the base the same and subtracting the exponents. And 5 minus 3 leaves me with 2 copies of 10 left over at the end of the day. So that gives us 4 times 10 squared. Here it's a little more difficult. They're making you write your answer instead of pick it from multiple choice. But again, I'll just go with the 4. Do not use the X on your keyboard. Either do Shift 8 like you see me doing here, or their times symbol, and then go ahead and go 10 squared. And at this point, I'm not going to keep showing a lot of these examples when they're simpler in the beginning, because I think you understand this. 4 divided by 1 would be 4. And then the powers of 10, we could just do 5 minus 2 to tell us, hey, at the end of the day, there's going to be 3 copies of the 10 left over if you do 10 to the 5th and you cancel out 2 of those copies of 10. So on that note, unless this one looks more difficult, I'm going to skip ahead to some of the more challenging problems. I think at this point you're good to do G5 on your own. But in case it gets more difficult up in the 80s or the challenge zone, I'm going to jump up to those to see if they add any more difficulty. And here we see our first one that they're going to add difficulty by getting negative exponents to be involved, or that's one way they will make it tougher. But my process, my procedure will be the same whether it's a positive or negative exponent that I'm dealing with. If it's two scientific notation numbers being divided, I'm going to handle the coefficients separate from the powers of 10. Now here, one thing they're doing that's annoying, 2 divided by 4. That's not quite as easy as this doing a 4 divided by 2. 2 divided by 4 is the same thing as a half, which if we write that as a decimal is 0.5. And now also I need to do 10 to the negative 7 divided by 10 to the first, and I'm going to put that in blue here. And I'm just going to take my top exponent, the negative 7, and subtract whatever's on the bottom. I'm going to be doing negative 7 minus 1. And that's just going to give me 10 to the power of negative 8. Negative 7 minus 1 makes negative 8. So here we've got, as our final answer, taking a look here, we're going to get 0.5 for our coefficient. And then we're also going to be getting 10 to the power of negative 8. And here's our issue a bit. As I look through these answer choices now, none of them say 0.5 times 10 to the negative 8th. And that's because this is not scientific notation. I need to go one step further. 0.5 can be converted to 5.0 by multiplying by 10, but we stole a power of 10 from here, so we're going to have to go down a power of 10 on the exponent if we made the coefficient bigger by a power of 10. So 5 times 10 to the negative 9th is what we're after there. And hopefully by process of elimination you weren't going to pick the first two, and since this one jumped by 2 powers of 10 but we only had to move one decimal point, we knew we needed 5 times 10 to the negative. And the next one is getting even more annoying. Beautiful. 1.08 divided by 7.2. So we're going to show this one out here. And definitely I'm seeing that G5 goes from being kind of easy in the beginning to much more difficult once you get in the 70s and 80s. That's okay, we need some challenges. I'm going to go ahead and write this whole thing out first because this problem's a little tougher. One of the ways they're making this tougher is just quite simply by making the division not at all friendly. I've got 1.08 divided by 7.2. And there's a few ways to attack this. You could write that as a fraction and try to start simplifying the fraction. I think that might be the easiest way, actually. I'm going to go ahead and just kind of show this with the standard division algorithm. This is the same thing as 72 going into 10.8, and 72 goes into 10.8 only once. And what we get out, if you did that out, is we get 0.15. Then you see on my whiteboard one way I could have done that. If using the standard algorithm, I got to 0.15. I could also use any kind of calculator. I would be okay with that because I don't think 1.08 divided by 7.2 is a skill we really need to be practicing right now. And that would give you the same on a calculator, 0.15. So that's how I handled the coefficients. I did that out using the algorithm. You could also use a calculator, in my opinion, if they ask you to do 1.08 divided by 7.2. And now that I've done that out, oh, I kind of used the wrong color, but whatever. The coefficients lead to 0.15. And separately, I need to do those powers of 10. I'm going to be doing negative 1 minus negative 2. And I'm going to write that out because that's difficult too. 10 to the power of negative 1 minus a negative 2. That's what's happening there with those exponents. And I know subtracting a negative number is the same thing as addition. Negative 1 plus 2 gives me the power of 1. So when I do 10 to the negative first divided by 10 to the negative second, I get 10 to the power of 1. But, and this is a crazy problem that should have been in the challenge zone, I need to move the 0.15 into a number that's bigger than 1. In this case, 1.5. So I borrowed a power of 10 to make this 10 times bigger, so now I'm 10 to the power of 0 there. And our final answer is 1.5 times 10 to the power of 0. Now, I do believe that these do get quite difficult. Once you're in the 70s and 80s, and especially challenge zone for 90s, they're going to get tough. They're going to potentially give you decimals instead of whole numbers when you do division with the coefficients. They're going to make you switch over into scientific notation at the end. And I'm going to show one last example here. But I'm also going to give you the caveat that it's okay to reach out to me directly to ask for some help as you get to the end of G5. So here's the last example we'll show together. I would encourage you to pause the video, try to do this one on your own before watching me. But the first thing I'm going to be doing is I'm going to be dividing those coefficients. I have 1 times 10 to the third divided by 5 times 10 to the negative second. And my first job is going to be dividing those coefficients. And I know that 10 divided by 5 makes 2. So I know that 1 divided by 5, 10 times smaller than that, just makes 0.2. And I'm also going to have to handle those exponents, 10 to the third divided by 10 to the negative second. And I remember that whenever I divide the same base terms, I take the top exponent, in this case the 3, and I subtract whatever exponent's in the denominator. In this case, I'm subtracting a negative 2. And this rings a bell. Whenever I subtract a negative, the opposite of subtraction is addition. Subtracting a negative really just means adding. And 3 plus 2 would give us 10 to the power of 5. So here, for our answer, we're going to get 0.2, that's from 1 divided by 5, times 10 to the power of 5. That's what happens when we simplify the powers of 10 that were divided. And again, another difficult problem because 0.2 is not scientific notation yet. I need that coefficient to be bigger. 2.0 would work. But because I made my coefficient 10 times bigger, I stole one of the powers of 10 to do that. And now it's really 10 to the power of 4 if the coefficient has been bumped up to 2.0. So again, quite a bit of work as you get to the end there, but all skills that we think you've built up and able to do now. Feel free to reach out to us directly if you're a little unsure and still want some help towards the end of G5, because it is a challenging assignment. Again, other than that, thank you for the great, strong work. Keep it rolling, and much appreciated.